So what are we going to do with the normal distribution? What we're going to do is we're going to learn how to calculate some things with the normal distribution. I just want to stress that there's lots and lots and lots of different distributions. And if you ever take stats in university, you're going to be going through all the different types of, you would do different types of distributions. You wouldn't be stuck to just normal distributions. But grade 12 high school is only a normal distribution. It's the easiest to understand, and it's also the most useful, as it turns out. So let's say, for example, I'm going to have an example. Let's do an example. I'll say the mean height of boys at Mayfield is 172 centimeters. With, I just made this up, with a standard deviation of 7 centimeters. And so that's the setup. And so the question is, what is the probability that a random boy is taller than 165 centimeters? So we're going to make our kind of normal distribution curve. And we know that the mean is 172. And standard deviation 7, so we know that that's a bit higher. We know that that's a bit, that's 7 below. 158, 186. So, what I want to know is, the question is, what is the probability that x is bigger than 165? If the question asks what's the probability that a boy is exactly 165, of course the answer would be 0. Which is why you may ask, am I asking if it's greater than 165 or greater than or equal to 165? And the answer is, it doesn't matter at all, because the probability of being 165 is nothing. So the probability of being taller than 165 is going to be all this going out to, this asymptotically approaches 0. It never actually gets to 0. So it's going from that to infinity. Now we know that from this sheet over here that we did on the previous video, that this is 34%. And all of these, remember the mean is, it's symmetrical around the mean, so all this is going to be 50%. So the probability that we are above 165, given this setup over here, is going to be 84%. Right. And then I could say example 2. So let's assume it's the same setup. What is the probability that the boy is between 158 and 179 centimeters? And again, I will set this up, and that's 172, should cheat a bit, 165, 158, 179, 185. So the probability of it being between there and there is this over here, which is going to be 34 plus 34 plus 13.5, which would be 68, 71.5, no, 81.5. And the way we would write that is that the probability that 158 is less than x, which is less than 179, is 81.5%. Now, the interesting thing about using a normal distribution is that we don't actually even need to know the details. We could do it in a different way. I could say, for example, what is the probability that a z-score is less than So the probability is z-score is less than 1. So the z-score, as you may or may not recall, is the number of standard deviations away from the mean. So at the mean, we are 0 standard deviations away from the mean. When we're 1 standard deviation away from the mean, we're at 1 standard deviation, 2, minus 1, minus 2. So what I've done is I've kind of changed the axis here. Before I was doing it in terms of actual values, but now these numbers are z-scores. So they're no longer numbers, these are z-scores. The mean being having a z-score of 0, and the other numbers having different values. So if I want to know what's the probability of having a z-score of less than 1, we've kind of already done that, right? So remember, this was 50% and this was 34%, so it's 84%. And notice we didn't have to know the x value, we didn't have to know the standard deviation, we didn't have to know the mean. It was all kind of incorporated into the z-score. Now, let's say I said, what is the probability that a z-score is less than 2.5? Nope, 0.5. Now I'm going to zoom in a little bit here. So I'm going to kind of zoom in on that part over there. So let's do that. So there's our thing, and there's kind of the bit. So this is the mean, and this is the mean plus 1 standard deviation over there. And remember, the area under the curve for this section over here is 34%. So the whole area, the area of this kind of light blue shaded area is 34%. Now, let's say we want to have the z-score over here, kind of halfway through. So are the areas of these two sections equal? And the answer is they're not. So this one's clearly bigger than that one. And by how much, we don't know, but this one's more than half. So this one's going to be more than 17%, and this one's going to be less than 17%. And to actually calculate this, you're going to need something called integer calculus. And you don't know integer calculus yet. That's something you will learn in university. And in fact, calculus was invented for finding the area under curves. And even worse, we would have to do it on that horrible equation I gave you earlier. So instead, what we're going to do is, yours may not look like this, but I gave a file that has a z-score chart. So there'll be a lot of numbers on it. And we're going to do something like that. And what the z-score chart is, it essentially does that work for you. So notice there's a negative side. On this side is the z-scores. I'll explain that in a second. And on this side is positive scores. So what happens is we are going to, let's say I want to know what is the probability that a z-score is less than 0.5. So this chart actually only gives less than. This is the probability of being at the given z-score or less. So what I would do is I would look for 0.5, and the probability is right over there, 69.15. Now, in the previous question, I said, what's the probability that z is less than 1? And that was this one over here. And we said that the answer was 84%. So let's see how that stacks up. So if we look at 1, right, it's going to be over there, and it turns out to be 84.13. So it turns out to be 84.13. So this is the correct answer. My 84% was kind of an approximation. It actually is 84.13%. That's the probability. Now let's say I want to know what's the probability that z was less than 0.73. So what I would do there is I would go to 0.7, and then this gives us the hundredths point. So 0.7, 0.70, 71, 72, 73. So it'd be over here, it would be 76.73%. So that would be 76.73%. So what I'm going to do now let's give you a couple of examples. So we want to know, what is the probability that z is less than 1.32? What is the probability that z is less than negative 0.84? What is the probability that z is less than 0.29? And what's the probability that z is bigger than 1.5? So I would pause the video right now and print out a z-score chart and see if you could do it yourself. So the answers are, assuming you've already figured them out, we're just double checking. So this is going to be 0.9066 or 90.66%. I'm cheating here, by the way. I looked these up in advance. And then the next one is going to be 0.2005, which is 20.05%. And I should probably show how I'm doing this, though, right? So for the negative 0.84, I have to make sure I'm on the negative side. So negative 0.8, 0.1234, that's a 20.005. 0.29, 0.2 over to the 9 is 61.41. This one's different. So this one I'm asking for the probability that it's greater than the given z-score. So what we're going to do for that, we're actually going to use the indirect method. So what we're going to do is, so that's 1.5, and the chart only gives us the probability of it being less than. So the probability of being less than 1.5 is 93.32%. So that's 93.32%. But I want the probability of being in here. And so the whole probability is 100. The probability of not being there is 93.32%. So therefore, the probability that z is bigger than 1.5 is the same thing as 1 minus the probability that z is less than 1.5, which is 1 minus 0.9332, which is 6.68%. There you go. And I'll do some trickier examples in the next video.